Okay. So I will have, on the final, I'll have a section like number 2. But to be honest, you should also expect maybe a few where I don't identify what to do. Like number 1, I say to classify them, but you don't have to solve them. So you have to be able to classify them. And then you have to be able to solve whatever procedure you figure out you can use. I kind of try to make, I don't know how close I got to doing this. If I'm you, the way I would always study is, I'd almost be able to say, okay, chapter 3 was this, 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 this. Chapter 4 was this, 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 this. Then you're pretty sure you've got it, the ideas down, and then you go look at each one specifically. So chapter 2 might be one you definitely want to hit. The integrating factor, we've seen that every now and again. So that's not one that's lost to time. But homogeneous, the first definition we looked at, Bernoulli's, some of those certainly leak out the brain because you don't see them as often later. But it's really wide open. What do you guys? Yeah.
By as completely as you can, you mean like stating it's linear, non-linear, it's one order, it's in, like that as well.
Yeah, classify. Yeah. So if I gave you a problem like that on the final, there'd be certain number. I know everything that you could say, and I would give you full credit if you said like a certain percentage of those things. Like there are 5 things you could say, and you said 4 of them.
Okay.
I'd probably be fine with it. So, I mean, for example, 1A, this would be an interesting one to do this for, but
Thank you.
1A, who's got something about 1A?
Well,
So we have somebody saying it's linear. It's a little hard to believe with the e to the y. All right, y is your dependent variable, so there's obviously a term where it's definitely not linear, right?
oh
Yeah.
it's separable.
Separable, I love it.
Autonomous.
Autonomous, sweet. I was hoping for that. We just talked about that a second ago. Okay. And let me see. Really basic. Think really basic.
ODE.
ODE, I love it.
First order.
No. Yeah, there you go. First order ODE, I love it. Yeah, cool. Those kind of things are what I'm talking about. And so, if you didn't hit every single one of them, that wouldn't kill me. But if you missed 2 of the things you could have said, then maybe I'll start taking points off. If I did a problem like that, I don't know if I'm going to. But I had a request to do like a phase portrait problem. You want to do the one that's on here or a different one?
Maybe the other one that's on there.
All right. Let's do this. If you want to play along with this, it's number 3 on the practice final. And each of the critical points for this represents a solution, right? Y equals 0 makes this true. Any constant is going to make this side 0. So the constants that also make this side 0 are solutions themselves. And that's the whole idea. If you're born there, you stay there, right? You have an initial value that's on that one of those things, you just stay there. And if you're not born on them, you can't get there, they're asymptotic. It really makes sense when you look at the fields, right? Okay, so try to get as far as you can with that. And we can do that problem. I don't have the answer key until Wednesday, but we can look at these problems, sure. Maybe if I think about it, it's always good. You can kind of make this for yourself too, but I like to do like for my stats class, I have a final exam checklist. It's got the basic ideas from every chapter, and you can just use it to check it off. If you feel pretty confident about it, you just check it off, right? You need to kind of do that for yourself, or we'll see if I can remember to do it for Wednesday. Gianna, did you need a copy of the... You need a copy of the press. I got one. You got one? Oh, wait. No, I don't. Huh. Oh, okay. Now, there's you need to identify the things that are pre this class that you might need to review, like partial fractions. I mean, that comes up all the time. Factoring, especially with Jeff, it comes up all the time. But I mean, to be honest, in calculus, anything involving derivatives, you often get things that you have to factor, and that will factor. I mean, people are always like, factoring is made up, contrived shit. Normally, if you just make something up, it's going to have to use quadratic or something. No, to be honest, a lot of these things, the way the derivatives work, you get a lot of things that that are factorable. So you still need to know how to factor. So this kind of problem, I would probably not start it off here. This is factored for you already. That is nicer than you know me to be. But what are the critical points here? Pretend like that's what you guys said. So those are going to be locations of what? There's two things you could say there. The thing I already said, they're locations of constant solutions, but they also act as asymptotes for the other solutions, right? That's what I mean when I say determined by the graphs of the equilibrium solutions. They are graphs of the constant solutions, but they also act as walls for the other solutions. So if you make just a phase portrait, right, my y-axis has a high wind coming in from the east. All right, so what do? So please refrain from putting the arrows for the axis in there, because that gets a little confusing for you and me. Multiplicity helps out a lot. If I just say that word, you guys remember what that means? Everything's multiplicity 1, so it's going to change sign around everywhere. So all I do is identify 1, and then I know all of them. That was the powerful thing you should have learned in pre-calc. So if I put a 1 in, I get positive, positive, negative, so it's negative in here. So then it must be going up, down, down. Crap, I got that song in my head. Down, holiday inn. All right. And then, so here, so this is the phase portrait. I definitely need to be able to see that. Now, I'm okay with you doing stuff on top of it as long as I can still see what's going on. So here are my equilibrium solutions. Put solid lines in there, it's not going to kill me, it's fine, because they are solutions. And you should be able to draw in here now, why does drawing like this make no sense? somebody could argue, well, it's going up, Jeff. The slope is going up. But drawing this implies something interesting up here. There's another asymptote. There's no other asymptote up there. I would have found it. So, I mean, what should this shape be? Yeah, it should approach the asymptote here, and it should go increasing. And will it be exactly that way? No, it depends on what the initial value is and so forth. Be really careful. I'm not going to be like stupid picky, but if you did something like this, do you see how I have to say something? Or in this case, just take points off because you might never see it. You know, that's kind of also implying that there's something up there that's a limiting factor, but nope. And then, of course, in here, should be, what's it going to look like? It's going to start.
Between the two. Starts up, goes down.
Starts up, goes down. I like it. So it looks like this little S, dude. Little backwards S. And then this is going to look like
The opposite of that.
the normal S, right? And of course, this guy is going to look at this guy just the other way.
Yep.
Oh, you take points off for myself. Well, too bad, Jeff. Now, I could ask you to do just general looks for all of them. Or, of course, I could do like I've done before, say, here's the initial condition, draw the shape. And it totally depends. It doesn't depend on this at all. It depends on this, right? So if I say this, then what region 1, 2, 3, 4 am I in? 3. The output's -1.
Oh, yeah.
Yeah, I'm between 0 and -2. So I would draw this, and I would just make sure to have 7, -1, you know, to have it go through that point. Doesn't have to be perfect, but you got to show me some idea of scale and put it on there. Don't just go, no. Is that cool? Is that all right for that problem? All right. Now, the book got into, I mean, I could ask you this, but probably won't have the space to ask you or the time to ask you, but you remember you investigated second derivative and concavity and stuff like that, inflection points. Obviously, I mean, just by what we've drawn, I would expect the inflection points between these two and these two, right? And also, at these asymptotes it could be, right? But I mean, that's why we would do the second derivative to see what happens. But anyway, there was a whole problem about that, not a big deal. So is that it's number 3? All right. So where do you want to go from there?
Homogeneous or any given homogeneous on it?
Yeah, 2E, I think if I remember correctly, 2E might have come out a little worse than I intended. So let's try it. Let's start with the first few steps. Now, you do have 2 main ways you can go with this. Do you see how every term is the same degree in a weird way? Even this one? You feel like y equal x, then this is still second degree. Sometimes that's a good indication that homogeneous, that substitution is going to work. You could just use the substitution if you notice it, but how do you force the ratio to show up? What could you do to force that ratio to show up? So what ratio am I talking about? There's 2 possible ratios. And I really don't care what letters you use. You can even use W if you don't like U or V. U and V are always evil for me because they look the same when I make them. Well, what are the substitutions we could use? Y over x or
X over
x over y. I love it. You don't have to make one of them v. It doesn't matter. We should know that by now. It doesn't really matter what letter you use. It doesn't really matter what letter from what language you use. It really, a happy face and do D happy face, whatever. So, I mean, one way to force I could either divide by x squared, or I could divide by y squared. Either way I go, it's going to show up. Anybody notice something that might say one way is better than the other?
X squared. X squared,
Would be better to do x squared? Why do you say that?
because there's a square on the other side, too,
Yeah,
on
so,
the bottom.
oh, I see. But you see, if you divide by y squared, that would take the degree down here. It would just be a squared u or whatever letter you use. But okay, so you're the only one that said anything. Let's divide everything by x squared. Of course, my fours. Must be careful with those. And then you can make the substitution. You don't actually have to do this step, which several of you found out. If you could tell it's homogeneous, you just make the substitution. It's kind of nice when you can see the ratio, though. So here you're going to let u equal y over x. Bless you. So then y equals ux. So then dy equals...
U prime X.
Oh, okay. So you could do u dx plus x du. Is this coming back? Vaguely familiar? Okay. And now you make the substitution. So let's see. U equals y over x. So this will be 2 plus u squared.
Yes.
Yeah, dx plus 1 minus u4, and I know what dy is. You always have to do some kind of a foiling situation on one of them. So then you do like I said, you foil that sucker out. Not too bad. Let's see, you get u dx minus u5 dx plus x du minus x u4 du equals 0. Really need that. So you're gonna suck all your dx stuff over here. Alright, so I get 2 plus u squared plus u minus u5 dx plus, yeah, I like it. Then I got my dy stuff, or du stuff, gather, we'll go get dy. X minus xu to the fourth du. And what is it you're trying to do with this now? Remember, once you make the substitution, you can separable. I love it. So you can see this is factorable. You can get your x stuff together. That looks yummy. So I get, let's see if you guys can see this. So I get dx over x. Well, let me pull this over. I hate writing so much. Let's see. Let me just factor this. Oop, not equals there. So I pull it over. So I switched this around, right? Subtracted it, brought the negative inside. Then you divide by x and you divide that business. there? I can't remember. Let's see.
What'd you do there with that, when you factored out that X? You just factored out a,
Well, see, I subtracted it, so I switched them,
oh, okay.
and then I brought an X out.
Okay.
Yeah. And this is where I'm not sure if I created something that was undoable or not. I honestly can't remember if I found a way forward. I mean, here, what are you trying to do? Can you factor the bottom? That looks pretty disgusting, right? So you could try synthetic. It is possible I created one that you can't go forward from. That would be horrible. That'd be too bad. Like, you'd hope to God maybe U sub would work. See how that's a fifth power, it's a fourth power, but U sub doesn't work because if you let du, if you let m, let's do m sub, equal the bottom, you don't get the top or a multiple of the top. Right? You would get 5u to the fourth plus 2u plus 1. Damn. Right?
What if we do reciprocal of it? Like, so minus u to 5 over u to 4 minus 1,
And then what?
and then take the derivative. So it's gonna be d over dh. So x times du over dh.
So if you flip this over, that would be effectively putting it underneath here.
And then move it to the other side.
Move it to the other side. But see, there's no x in it. All right, so stop there. This is the one that I think I put on the answer key done in class, because I think this is the one you get to a certain point and you can't go any further. Which is fine. I just made something and made a change without double checking it. At least I could do that on the practice test, right? Don't worry about it, it's not going to happen on the actual test. Yeah, so I mean, if you want to, you can try to see if there is a way to forward. Even if you, well, let's see, I mean, it's not impossible that this is factorable. You have to use synthetic division to try to see it. It's not impossible. Q minus 1, that doesn't really work too good, no. Okay, all right, so enough of that one. The important thing on this guy is to remember the process of how to move forward with this. Okay. I think that's the only one that I said I wanted you to do using homogeneous stuff. Yeah. Okay, I think my mistake was something here. I changed something and didn't double check that it would throw things off at the end. I think before there was stuff that canceled here that doesn't cancel anymore. So. Okay.
I got one that maybe that's not on test. Could we do an example of solving a DE through order of reduction?
Oh, look at number 5. Read all the one from this. In all your free time, you can see about going forward from there. I don't say explicitly use reduction of order there, but if you look at that, what method, if I just gave you this DE by itself, what method would you try to use to do it? I just said solve this. Is it Cauchy-Euler? No. Why not?
Because there's no constant, there's no coefficients out front that we can use.
This is kind of related to x here, so you can maybe think it's some kind of modified Cauchy-Euler if only this was squared
Yeah.
and not 2, for example. So there's There's things you can modify Cauchy-Euler, but this is not even in the right form. What else would you try? Series. You would try series. You would not
Yeah.
want to that much, but that would be what you would try. If I just gave you the student and said, solve this, which would be kind of evil on my part. You have to realize you have to use series. So here I'm telling you one solution. If I give you a solution, ask you to find another independent solution, that really means use reduction of order. And how the hell do you do reduction of order? Oh, is it e to the 2x? Yeah.
Y equal to U e to 2x.
Yeah, so assume y is equal to u e to the 2x. So on one level, it's just another way to assume the form of the answer and then to use that form in the problem. Right? That's how we solve for yp, for example. Right? This is not that. And of course, this idea, what's this idea based on? It's kind of given away in the question.
Linearly independent.
Yeah, it's the only way that e to the 2x and something else can be linearly independent is if the ratio is not a constant. It's a function of x. It's really kind of cool, to be honest. We just go, well, this has got to be true in order for do it. Let's try to just use this shit. So, holy shit, it works. So it's kind of nifty. So then you start doing your y prime and your y double prime. You get all these product rule business coming out. Right, because they're both functions of x. Is that starting to come back?
Yeah.
Okay. So it's not variation of parameters, which is exciting by itself. Which one was that?
Would be able to use the equation or not?
Part G. Oh, the shortcut?
Yeah.
I was about to say you don't know me yet. So no, you can't use it unless I say you can.
You said that already, though.
I know. It's okay. So, do you guys want to keep going with this, or?
Yeah.
Yeah? Go ahead.
So,
I mean, if you just watch me do it, you're not going to get shit from that. That's what I would have done. No, come on.
What do you mean specifically by shortcut variation of parameters?
Huh?
Was where you said like shortcut of variation of parameters? Like, what do you mean specifically? What is the difference between doing it the right way and the shortcut?
No, it's not a right way, wrong way. It's a
There's
What
a
he
good
wants.
way. Oh, there's a good
it's
way.
a shortcut. And if you don't understand why I have issues with some shortcuts, then oh well, it's too bad.
because it's good to know what you're doing, where it came
Yeah, it's
from.
good to know where it came from. Some shortcuts hide way too much.
I said,
And then you can't, the important thing about going further in math is to be able to make connections to things you know from earlier. And the less you know those things, the less connections you can make. The less connections you can make, the less attached you are to the math, and the less it makes sense. That's why I'm not a huge fan of songs and foil and sayings and SOHCAHTOA and bullshit. Sorry. I like singing the songs. Sing the songs, so. Just understand it. That's nice and relaxing. I'll request that for fun. Like that somebody says, "Oh man, I sat on my keys." That's my car. Let's see. So like, some of you guys have this very constructionist approach. And what do I mean by that? You construct the parts you need, and then you throw them in. I love that. There's nothing wrong with that. I kind of do this weird thing where I just line up all the terms. What is it that you're looking for? What is it that's happening right now that tells me I'm on the right track?
U double prime, A prime, finally, yeah.
The U terms
cancel.
cancel, yeah. So you're just left with U double prime and possibly U prime. Right? Remember, sometimes the U prime even goes away. So these are gone. That's nice. That tells me I'm on the right track. Because again, officially it stays second order, but because there's only another first order, I can look at it as really a first order thing in a new variable. That's why the reduction of order is what this is talking about. So I need to have that out of the way so I can look at it that way. Let's see, so then I get 2u. Plus 4u prime x into 2x equals 0. So all my e to the 2x's go away, right? And I can change it to, well,
W prime,
true. Doing too much. So, I mean, you have to know the nuts and bolts steps, but you often also have to know what the goal is. What are those steps supposed to accomplish? So you know if you're on the right track. So if you have a U left alive, you know don't waste any time trying to go forward. You go back and go, shit, what did I miss? So here, what can I do?
You can group your U double primes.
True. I can also
simple one.
kill the
Oh, kill the E to 2x.
either 2x die. They can't be 0, so I can divide by them.
Mm-hmm.
And here I've got 2x plus 1 like I did from the beginning. U double prime plus 4u prime. Let me go ahead and make that w prime 4w. And now you can either do
It's separable.
separable or
Integer, but
integrating factor, linear. Either one. So that's the whole point of this, is it either becomes separable or linear, the integrating factor method, right? So it all depends on which way you like better.
Isn't it 4xw?
Oh, yeah, thank you. So that little x dude stayed alive. That makes the integrating factor a little more interesting. So if you did separable,
it's separable.
you would do dw, let's see. So if I did dw dx equals, where do you go? Negative 4xw over 2x plus 1. So I brought the dx over, and the d, and the, so I want this w down. And then all the x stuff stays with the dx. There you go. You still have to integrate this. I mean, do you see what I'm saying? So it's sort of like, that's why either way is going to work. You still have that. It's either going to integrate for the integrating factor, or you're going to have to integrate it directly. Let's see. So this side, and how do you integrate this side?
Oh, wait, you use separable? Separable? method?
Yeah, I use separable, yeah. Either way.
Right. We're being honest.
Now, you could either notice that the degrees are the same on the top and bottom of this, so long division, or you can be smart about what's to add and subtract. Do you guys understand one of those two ways? So as long as the bottom degree is at most as big as the top degree, you can do long division to break this sucker up. I can't use partial fractions, right? What the hell would that do for me? There's just one thing on the bottom. Ooh, I'm done. Right? But if you want to use, so again, you can use long division, which people sometimes just shy away from for the craziest reasons. So it'll be negative 4x minus 2, change the signs, I get 2, so it'll be negative 2, negative 2 plus 2 over 2x plus 1. I guess to be honest, I could have done this too. This is where you guys just have to see what you can do to get used to what's out there, the flexibility within the problem. I could have also done this. 2x plus 1 times negative 2 is negative 4x minus 2, right? So if there was a minus 2 up here, that would go in evenly, and I better put a plus 2. That would go into there negative 2 times with the 2 over that left. Holy shit. I mean, and I've seen some of you guys do something like that. So, you know, they both took me about the same amount of time, so who gives a shit which way you do it, whatever way you see. And now I can, I mean, hopefully you guys see that U sub wouldn't work here. Right? I mean, it sort of would, but it's just more than you need. So then what do I get? I get ln W equals
0, -2x,
negative 2x
plus 2 ln of
okay, so 2 ln
2x plus 1 times 2.
you're integrating.
Plus C.
I mean, yeah,
Oh,
plus c, but I'm not done with this. Because right now it'd be 1 over 2x plus 1 times the root of the bottom times 2, so it'd be 4.
Mm-hmm.
So really it would be over 2, the 2 that wants to come out. That isn't really, but it is there, see how I'm saying? So that was an exact derivative of that. There's no constant needed because the constant that would come out is 0. Okay, and then I like this problem. What's the next step?
So for U prime,
Yeah, so W was U prime, so I get U prime. And of course, how did I do that? I had to do what to both sides? E to both sides, so this will be E to the negative 2x.
plus
Yeah, E to the negative 2x plus, which is E to the negative 2x times E to this. Is that cool? You add powers when you're multiplying the bases. So E to this just makes it 2x plus 1, absolute values, be careful. And then E to the C will be a C out front. C1. This will be E to the C times that. This is where some of you guys definitely trip up. If I do E to this whole thing, this E to the negative 2x times E to this, because that's when I add powers, is when I multiply like bases, times E to the C, which is its own constant. Now that looks exciting. Oh man, this problem is so yummy. We do have a little more time for the final, but I need you to understand, I'm not necessarily going to do a problem where there's so many things happening. But on the practice final, I felt free to just throw some stuff. So you gotta, when you're studying, you gotta separate the process from the details of the problem, right? If you're getting stuck in the details, don't sweat that so much. If you're getting stuck in the process, shit, that's a problem. If you don't know what to do next, or if you're not sure about what you just did, that's a problem. If you're like, what do I do with this integral? Okay, that's not like a major issue, right? Unless it's integral of sine or something, then that's a major issue. Because what do I have to do next?
integer.
Yeah, integrate. So, what's the screw it, let's just take this out. So we get U equals integral of this side. In fact, this side can only be positive. Let's screw it up there. And the C is going to suck in any negatives and shit, right? It would be either this equals this or this equals negative this.
Mm-hmm.
And the C would suck that in anyway. So how am I going to integrate this side?
You have to do a U sub for the 2x plus 1.
Yeah, you're gonna have, yeah, exactly. So you're gonna have this piece, which is gonna be by parts, and then you have this piece, which would be easy, right? So when I'm studying, this is the point when I might be like, what would I do once I do this? How many steps away from the answer am I once I figure this integral out?
Like
Just
everything
converting
back.
back.
I'm how many steps? One step. Because the answer is this. I'm about to figure out what u is when I finish the integration, right?
Because you have to convert back as well.
Yeah, so if you're like, I know by parts, I just don't feel like doing it, screw it. You know exactly what you would do next. The process is what's most important here. Now, if you don't know by parts, then you want to do that so you get to practice, right? Anyway, is everybody cool with what would happen here next? Okay. Anybody want to see it happen? I mean, the part of this that's semi-grossest is just this integral, this piece here, the integral of 2x e to the negative 2x. Even that's not that bad, right? What would you let u equal? 2x, always the polynomial piece, almost always the polynomial piece. So then dv is the other stuff. So then v is e negative 2x over negative 2, I like it. So you got uv minus the integral of v du, which is beautiful. Okay, not too bad, not too bad. So the important parts of this were what gets you started with this? And also the very first important part was what part of what I said told you to do this? There's no other way to do it besides this. Unless you want to do series, and why would you do that when you have one of the answers staring in the face? So that's got to be a reduction of order, right? So when I know an answer and I'm looking for a second linearly independent answer, that's reduction of order, right? Especially when I have a funky ass DE that I don't know how to do it unless it was series. Yes?
Was that by parts for that, or was
Yeah,
it just
just this
example of
piece. You see distribute? Now, to be honest, you could actually keep it together
it? And it was
and do this
still
whole
work?
thing at once. Because then u would equal this piece.
Yeah, that's
Totally.
what I did.
Totally. That would work too. Yes?
When you do, when you solve a DE using Laplace transforms, it doesn't work if you don't have initial values, right? Or can you do something?
I mean, technically, the problem is when you get to the partial fraction decomposition, you don't have a specific top. So technically, you could go forward. It just, you get these, you can solve for A and B and C in terms of those unknown things. So technically, you could go forward. In fact, sometimes I'll do something like that just to figure out what numbers would make it work nice. You know what I mean? So I just put W and Z in there, and then and I'm like, oh, if W is 4 times Z plus 2, then it makes it work nice. Oh, good. Let me just make those numbers, you know. But yeah, in general, it's kind of, it's not that it doesn't make sense going forward, but that's basically when you use Laplace is when you have actual initial values. You don't have to, though, to be honest. It's just gross. Oh, that's not too bad. I just had a couple people that were trying to use the definition of Laplace. I only use, and what do I mean? What do I mean when I say the definition of Laplace transform? Yeah, the integral of the kernel, blah blah blah. Only do that when I say use the definition. All right. Like number 7. There are some examples in the book that are like that with piecewise functions. Yeah.
Can we do number 4? This is
Oh, sure. So please understand, on the final, it might not start off with that. And most of you guys are used to collecting your X stuff, like D plus 2, X, and stuff like that. Some of you guys didn't, which made the whole problem a little harder than it really should have been. Something else that's happening every now and again, what is wrong with, if you saw on somebody's paper, if you saw this on somebody's paper,
They're
Oh,
X's.
it's not on.
doesn't make any sense. It's sort of like saying the square root of 9, right? This doesn't make any sense. Square root of 9. So this of this, operating on this. This doesn't make any sense. Now, a few people that did that kind of went forward correctly, but for the wrong reasons. So anyway, so let's see. What's this thing look like? So now it's just really your choice.
It's not because you have to solve for x.
Say again?
You have to solve only for x, not for y. I mean, the question says solve only for x.
Oh, why does it say 4x? Oh, solving it for x. That's, I don't know why I said that, to be honest. Oh well, who knows what I was thinking. So if I want to solve for x, then obviously I'm going to kill the y. I don't know why I wanted to do that. I'm not going to say anything like that on the phone. I'm just going to solve this thing, and then it's up to you. So how will I kill the y's?
Multiply by d minus 4.
Yeah, operate on this first one with d minus 4. There, there, there. So then it becomes d minus 4, d minus 2, x minus d minus 4, y equals,
Negative 18.
yeah, derivative of this. So sad et. And then
Plus 4.
negative 4 times this. So plus 4 et. Some of you guys weren't exactly sure how that worked, but one of them is just derivative operator of that thing, and then the other is just a multiple of that thing. And now I can add these together, so then I get d squared minus 6d plus 8x minus 3x die equals, this will be 3 to the t minus 7e to the t, so minus 4e to the t. Is it? Some of you guys got, you lose things. There was just some interesting things. I can't even capture it in one sentence, really. But dear God, do this for yourself. Be very systematic. I had people kind of doing stuff over here and doing stuff over here and bringing it back together, but things are moving sides magically when they should change signs when you do that. I mean, you got to be a little systematic for yourself, right? This becomes this. These two combined become this. You can see it nice. Makes it really easy to read. And then this, of course,
Factor x out.
well, I mean, so you get d squared minus 6d plus 8x minus 3x plus 5x. Some people added this 3x over and then did some really freaky stuff. I need you to realize this side can only be a function of t. If there's x's over there, you've done something wrong. And now, how do I go forward? This is nice. Yeah, the auxiliary. So I'm cool with you doing this and then actually going straight from there, but just be careful. You're not figuring out what D is, really. You're just kind of shortcutting and not bringing the M's in, but D can't equal something. That doesn't make any sense. So I can see the auxiliary there. So I know the the XC,
Yeah, 5T
yeah, e to the 5t, C1 e to the 5t,
plus C2,
T2 e to the t. Ooh, I like this one.